relearn something. I am actually pretty nervous right now because English is not my native tongue. Also, I am going to be do the relearning thing. Actually, I am going to relearn the econometrics. Why I did the econometrics? I like it because I like the math. I like the ideas. I like the discovering ideas. Also, uh, I like the thing, the causality in the econometrics. It helps us how to understand the things. It helps us to analyze more correctly. I like that. Also, I like the mathematics actually, and I like the fact that always chasing the truth. It's kind of an epistemological philosophical question, which is why I'm really interested in this area. I'm trying to do as much as I can. It's my first time doing YouTube videos. It's my first time doing any kind of presentation or teaching. Not teaching, but screening something. Uh, I like I said, English is not my native tongue, so I might use the terms in terms in correct ways, or I might have understood some things in the wrong way. If you find out something like that, please share your opinions with me. If logic behind the any operation, if I understand the logic in the wrong way, please correct me. I want this to, thing to be a journey for me, and I also want this thing to be a journey for you. Like I said, I'm nervous. I'm hoping this journey will help me to help me in improving myself. It's kind of a challenge, and I'm planning to upload the videos regularly. After I finally covered the area of econometrics, I'm planning to do on some other stuff. So this channel is not probably only aimed at uh, uh, econometrics to do the econometric tricks, but it could be a philosophical in the near future, or could be based on the social sciences or anything else. Uh, my aim is going to be journey is and this channel will help me to understand, to rediscover the things, and also I think it will be my way to establish something in the world. It could be a legacy for me. I hope. And like I said, so today I'm going to be only mentioning the basic terms. By the way, I'm using the books on which is written by Stacks and Watson. The book's name is Introduction to Econometrics. I find this book helpful because it's narrative-based books. Also, I think it starts with all the basic things. It starts with the probability theories, and it also uses the statistics is and describes it and mentions it. It's also an introduction kind of a thing for the econometrics. So, because of that, I will be starting the probability, and I will be starting the thing in the terms, the basic terms. This first chapter, like we said, I will be covering the basic terms, the point of that I understand, and I hope you guys like it. I don't know. We will be discussing. So the basic terms. Let's put our titles first. Titles first. So the book starts to describing the sample space. Sample space is a set of all possible outcomes. What do we mean by this? Let's say for an occasion, you describe a possible. You describe when you describe the all possible outcomes for this occasion. This will be your sample space, and it's basically like that. For example, rolling a dice. The outcome of the rolling a dice will be either one, two, three, four, five, or six, and the sample space of the rice will be the one or contains the one, two, three, four, five, and six. An event is another term in the book. Is event is a subset of sample space. So if you say that an event which is the result of a rhizome is equal or smaller than 3, this is an event. Yeah, I mean you are describing the outcomes of the role will be having a 1 or 2 or 3. And this is the event. And theoretical approach, this is a subset of sample space. And the third description is random variable. So random variable is numerical description, numerical terminology for an outcome. So you are representing with the numbers instead of the words the outcomes of the sample space or event. And like we can describe anything any way we like, by the way, and you can juggle all the things in this here. For example, let's juggle this. Okay, let's say we describe the sample space, right? Dice roll, sample space of or a rice dice roll as we want to 3, 4, 5, 6. Maybe I mean we are assuming the dice have 6 faces, right? Because of that, we are saying it can have 6 possible outcomes. If we assume that the dice have 4 faces, then our sample space will be different. So the random variable, and you can describe the outcome of one as 0, outcome of 2 as 1, blah 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 blah, and 6 as 5. And you can describe it like that. Okay. So you can create another sample space. You can create another sample space. No, not the sample space. You can. I mean, actually thinking, can we describe an event as a random variable? This is a theoretical question. Can we describe? Let's do it. Just describe an event as random variable. I think we can. So we can say that probability. No. Let's say what did we say? Dice roll having equal or smaller than 3, equal or smaller than 3 is an event. Let's say that is an event A. Okay. So A equals 1, 2, 3, 4, 5, 6. I'm sorry, no. It won't be about 1, 2, 3, 4, 5, 6. It will be 1, 2, 3. Right? Yeah. I can't delete. Okay, one, two, three. So can we describe another sample space for this, right? Dice roll having has one as a four, five, six. Can this be another sample space? I think it can because A is a subset, right? And it can. I think from the set theory, it can. But of course, you have to preserve the probabilities. I mean, in this here, we had the one, two, I mean, 1/6, 1/6, 1/6 for every outcome. So this probability will be 1/2 because 3/6 is equal to 1/2. So this subset has the probability of 1/2. This will have the 1/6. So you can describe some space as like that. You can juggle these things. So as you can see, this A can also be a random variable, right? Why not? Why not? I mean, this is a random A is having equals random variable having 1/2 probability, right? There is no contradiction in this. I think I assume, and you can numerically represent it this as zero, two as one. I mean four as one, and five as two, and six as three, right? There is no problem in describing this thing like that. So, by the way, random variables, I mean, we numerically assign these things. The magnitude of these numbers, the numbers we assigned, I mean, this zero, this one, magnitudes, or their rankings between them, or is not relevant. Is not relevant. It's just to describe some things. This is just for the describing things. I'm probability x equals smaller than 3. Let's consider the dice roll. Is mean that this means that we want to find the probability of the random variables. Uh, this what did we say for this numerical represented by 0, 1, 2, and 3. We want to find the probabilities of all things. So I mean it doesn't mean that the number of roll is 6 is important than the roll resulted in 2. And these things are not important. They doesn't mean any higher or lower or doesn't mean any importance in this set. And we describe the random event, we describe the random variable, we describe the event. And so let's go to the other terms. Let's delete this. Okay, I'm using Google Keep by the way. I think we are deleting it. And by the way, I'm thinking what was the next what was the next term? Yeah, probability, yeah, probability of an event. Okay. We will be covering this. So probability of a random variable is described like that. Yeah, we mentioned this. Actually, probability of and I'm gonna delete all these things, all the shits. I don't think this. I don't want this thing to be casual. Sometimes I might use slang words. I'm sorry, but I don't. I mean, I don't want this to be a formal thing. I'm not lecturing anyone. I'm just talking about the ideas. I just want to be a little casual. We are not in university or formal. education. What did we say? Yeah. Uh, Probability of random variable. So it is described as like that. X is uh, our event, not the event, but our random variable. Okay, and we want to understand probability of x equals one. This is the description. This can be described as the probability of. As you remember, we described the role resulted in one as zero, resulted into as one. So we want to know the probability of result of a dice roll is what? Oh, is two, right? Not one, because we described the two as one. Okay, this why is two. As we can see, like that. Is two. The second thing, the probability of event. Probability x is equal or smaller than 2. So what do we mean by that? We mean that probability x equal to 0 plus probability x equals to 1 plus probability x equals to 2. We find these events probability by summing their probabilities. By the way, we should note that these are independent events. This topic will be covered in the next in following chapters. Let's say not the chapter, but topics. Maybe we can say that. When this works only if the probabilities are not dependent; they are independent. When we consider the probability of x equal or smaller than 3, this means our dice roll having resulted as 1 or 2 or 3 and 4, we said 3, and we can say that everything is different than each other, right? So we can every possibility of the having 1 or 2 or 3 or 4 they are independent each other, they don't affect each other, we can easily assume as true, and we will find this by summing their probabilities. So the probability distribution is the next topic. I'm feeling like I'm feeling I'm talking blunt. I don't know the term. I'm as mixed actually. Uh, Maybe I'm covering the topics as too much, as quickly, not too much, but quickly. I don't know. By the way, while I'm talking about, there are many questions comes to my mind. For example, I'm not going to be mentioning right now because I think the questions are independent and trying to create a new syntax or and which is not necessary. Let's be honest. Why do we can assume that it's like that, or we can do this? Can we do tricks like that in this here? Maybe it can, maybe it cannot. But today and is it's not relevant. So I'm not going to talk about this questions like that. Let's follow the guide of the book. So the by the way, I'm mentioning these topics as far as I understand. If something is wrong, please inform me. If you find something is in wrong, if I understand some terminology in wrong way, please notify me. So I'm going to be told, the next thing is probability distribution. So the distribution of our probabilities. Yeah, I mean, let's consider some sample space, random variables, and their probabilities. So we have 0, 1, 2, 3, 4, 5, right? By the way, if you accept the random by the way, you can accept event as sample space. What do we mean by that? What do we mean? Let's consider the result of a dice roll equal or smaller than 3. 1, 2, 3. When we accept this as a sample space, so the probability of having each of these will be 1 over 3, 1 over 2, 3, 1 over 3, 1 over 3, and 1 over 3. Because this became our new sample space. We are considering an event like this. Okay? We are assuming that our sample space created by that. And if you sum all of probabilities in sample space, you will get one. Okay? Why do we mention that? You might need it. You might need it. You might need it. Okay. And I mean, in the event of, in the event of having a dice roll having smaller or equal than 3, what is the probability of getting 2? But in the event of getting equal or smaller than 3, and in this event, what is our probability of getting 2? This changes our probability to 1 over 3 instead of 1 over 6, because we are thinking this in the event of this thing, our probability will be like that. By the way, I'm not mathematician. I'm be covering some. I might be thinking uh, as serious assumptions or considerations, because these are kind of a fundamental theoretic things. By the way, like I said, I'm not lecturing things. I'm talking about the things as I understand. So I understand that we can. I don't really see any reason accepting event as a sample space. I mean, we are considering in the event of having these three, what our probability is having one of these, getting one of these. So it's 1 over 3. Okay. Let's consider our sample space of having the the dice having 6 faces. Right. So their probability distribution will be like 1 over 6, 1 over 6. They will be just dots, dots, and dots. So you can see this just creates a line. I mean, you don't draw draw the line because you don't have the probability of having, let's say, 4.5, because it's not a continuous variable, it's a random variable. So let's cover the continuous variable and discrete random variable. I mean, it's a discrete random variable, not the continuous random variable. Discrete random variable gets values like 1, 2, 3, blah 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 blah. Our continuous variable, random variable, gets minus infinity to plus infinity. I mean, it can get any numbers. So it's the continuous random variable is actually a like a flow. I think this is a good representation of their description. Let's say we have two sample spaces. In the sample space, the 1, 2, 3, 4, 5, and 6. This sample space is created by six blocks. Let's consider it's created by six blocks. So you can calculate the blocks area because blocks does have the areas, right? You can calculate these areas, and these are separated each other, right? These are separated from each other. These are separated. So this example of discrete random variable. I mean, everyone is concretely separated from each other. You can calculate the areas of this thing. Okay. I mean, this could represent the having a rice roll. Okay. However, let's say we have another sample space which is created by formed by dots. I mean, not by the blocks. The sample disk space is, let's say, that it's created by the blocks, but this is by the dots. By the dots. By the way, how many dots you have in a square or rectangle or triangle or hexagon? You have infinite amount of dots in. I mean, just finite line. You have infinite amount of dots, and also dots doesn't have any areas, and you can calculate the probability of the single dot because it doesn't have any areas, right? If it does have it like this block, I mean, you could have calculated it, but this doesn't have any areas. That's a pro. And it's like a flow because I mean, you can put any block in there, but not like that. I mean, no, I'm sorry, not block. You can put dots anywhere you like, and you can't calculate the area of a dot. So our probability distribution for the continuous why did I delete that? Because it was a good representation, I think, of the continuous random variables. Because I like this description. Mr. Stockholm Watson doesn't describe it like that. I'm gonna be bragging myself. I did it. I'm sorry. But la. But yeah, these dots are the representation of our continuous random variable, and it can take any values. You can put any number just concretely solely to dot. That also doesn't have any area. You can assume that. So in a continuous random variable, for just one outcome doesn't have possibility. It's a uh, it's a theoretical question, and as far as I remembered from the one of the three blue and one brown, I hope I'm saying the channel's name correctly. By the way, it's not kind of a YouTube content, but kind of a Twitch content. Uh, as far as I remember, I hope I remember the channel's name correctly because I like the channel three blue one brown, I guess, or three brown one blue. I don't know. I'm not sure, but let's say three blue one brown. He mentions that for just an outcome, probability of having just one outcome is theoretically zero. However, I mean that's just the intricacy of the math. Sometimes it's mind blowing, sometimes it's fascinating, but I like math actually. Because it's thinking, man. It's imagination. It's thinking. You can juggle things. You can do many things. You can assume and create things. Oh my god! Sometimes I wish I studied math, but the country where I live, if you're a mathematician, you do not have that much to just enjoy doing mathematics. Whatever. This is the probability of our discrete random variable. Okay. So these are just samples, the separated dots. Okay. So how our cumulative probability distribution will be like? It's cumulative. It's getting bigger and bigger and bigger. When you move toward the next random variable, the probability is getting bigger and bigger and bigger. Why? Because you are summing the probabilities. So it will be like that, something like that. Da, 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 da. For the dice roll, one, two, three, four, five, six. I nailed it. One, two, three, four, five. So this is probability x equal to 0. However, this is probability x smaller than equal to 1. So you have the probability of having x equal to 1 or x equal to 0. In this one, you are getting probability of x equal to 2 or x equal to 1 or x equal to 0. So you understand the idea, I think. So this is a cumulative, so you are summing. So you are summing the previous values to the current value. So you are summing the probability of the previous values like 0 and 1 to probability of getting 2 to get cumulative distribution in the probability of x equal to 2. So this is represented like that, probability of x equal to 3. In here, we will get probability x equal to 3. We are interested in just getting 3 in here. So the cumulative distribution, la, 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 la. Let's, this continues. The graph of continuous. For continuous. So continuous, we have probability density graph. Okay. They can say probability density distribution. They can say like that. I don't know. This is for continuous. You have infinite amount of random variables, right? Let's draw it something like that. This is so. Like we said, we cannot solely assign a just random probability of just for all the possible outcomes because it will be something like that. If you try to draw this thing like that, draw this thing, so you have infinite amount of possible outcomes, so which will be 1 over infinity, so you have 0 probability, so you have like this just dot line. It's just the line is equal to 0 to continue the probability distribution of a continuous random variable. However, to overcome this problem, guys, this is clever. They just developed a new thing. So they created this. They said that let's use the area under the curve to distribute to represent our probability. So they say that let's draw a graph which has an area under the curve is equal to 1. So the area of all the curve is 1. Okay, area equal 1. So we cannot describe that and also they said the mathematicians they thought that, I mean, we cannot say, or how should I say that? We cannot say that one. We can't say that probability of just one outcome. We can't calculate that. E. It's e. Theoretically, it's equal to almost equal to 0. So we can, however, we can. I mean, let's consider that. Can you calculate the? I mean, let's say that this is point 0.3. So probability x equals to 3. What is the area of line? The line doesn't have any area because it does have one dimension to calculate. Area, you need the two dimensions. The line just has one dimension. However, they said we can calculate the area right here. So probability of getting x equal or smaller than 3. And how do we calculate it? Let's just calculate this area. What is this area? If this area, let's say 0.65, I'm just making it up. Then it's we calculate it. We can calculate an event under the probability density of a graph. So they overcome the problem with the solution. I mean, you cannot draw a line like that, but you want to calculate an event. For example, you want to calculate the probability of having uh, a height equal or smaller than 1.7 meters. Okay, you might want to calculate it. And also they said that let's if you want to calculate in this area, what is this? Let's say that 4 and 5. So if you calculated probability of x bigger than 3 but smaller than 4, right? And what is it? How can you find it? You can find any way you want. I mean, you can calculate this area and subtract from it for, subtract this from this, or you can calculate this and subtract from that, subtract each other. You can calculate any way, right? And you any way you like, and this is your area. I mean, you can approximate, right? You can calculate probability 0.55 x 0.7, right? You can approximate. Maybe kind of the idea of Riemann sum could have work there. I mean, there are Z distributions, etc., etc., etc. Yeah, they have. Do they? No, they are based on the areas. I think. Yeah. They are. They show the area, not diagonal. Maybe you can approximate to your probability like that. I mean, you cannot calculate exactly 4.5, but you can approximated it, and you might find the ish. I mean 4.5 ish probability, but it will be very small because I know you see how your area is getting smaller. Okay, so this is probability density of cumulative distribution. Okay, now probability density distribution of continuous random variable, and also there's a cumulative distribution for continuous random variable. By the way, I mean, who comes up with these ideas? Who developed these tools? I mean, these are the tools, man. These are pure imagination. They are pretty smart. I'm just wondering how I mean, did they spend a lot of time on these things, or they are just genius? Many people said the Gauss was genius. Earlier was genius. I don't know. But these are pretty smart, man. I mean, if you how they if they just if it didn't occur just like a light bulb. I hope my pronunciation is good. If it just didn't occur as a light bulb, if they worked hard for this, oh, they are very determined people. They are very determined people. I mean, you know, it should take a lot of calculations, man. So our current probability distribution graph. So we have like this random variables. So it comes from negative infinity to positive infinity, right? Because it can have infinite amount of that. So it will be like that. Oh, it will be rising up and so it, it will be like that, something like that. Okay, okay. So cumulative probability, random variable. So it will end up in 1. Okay, so our, but by the way, it will not get to 1. It will approximate to 1 as we reach to infinity. Okay, why? Because we have infinite amount of random variables when we go through the, or it will be, by the way, like that. It could be like that. Why not? It's just assuming. Okay, you can turn it around. Okay, it will be like it will be approximating to 1. And this point, okay, there's a difference. Now your dots showcase something. Okay, you don't interested in the area under the curve, but you are interested in the values of the area. Because this is cumulative, you remember the cumulative, you are summing the previous values. So this is, let's say this is number 3. So this here will give us right here. So just think like that. The areas under this curve, the calculated areas under this curve is transferred into a line. Just think like that. So we have our cumulative distribution. Okay. And actually, the normal distribution is an important concept in statistics and science. It's kind of like that, not exactly like that, but I'm just assuming. But it's kind of a reversed Z shape, reverse Z shape, I mean. So you are not interested in the area under the curve for the cumulative distribution, but you are interested in the line, the values on the line, because you just represent these areas, just the dots on this line. So everyone, for the day, things I will be covering are these things. Thank you very much for listening. Thank you very much for sharing this moment with me. Uh, I hope you will have a nice day. In the next topic, I'm not sure, but I will be definitely covering expected values, variance, mean. These are the definites of these things. I will be covering this. Okay. Okay. But there will be another topics in the next episode. Yeah, thank you very much. I'm glad you listened to this. I hope you liked it. If you have an opinion, please share it. And I hope you will have a nice day. See you next time.